We are delighted to have Professor Eric von Hippel here to inaugurate our series this year. As you know, we have a number of speakers each year in these series, and Professor von Hippel is the first one. The next speaker will be Professor Hugenholtz from the University of Amsterdam, and that will be next month in October. So just keep that in mind. But back to Professor von Hippel, whom we are absolutely delighted to have here. He is a friend, a newfound friend of many of us, but the fact that he's newfound does not mean that he's already in the short period of time that many of us have known him has had a huge influence on our thinking. He is a professor at the MIT Sloan School of Management and is the head of the Technological Innovation and Entrepreneurship group there. He has been working for decades on issues surrounding innovation, particularly in a very interesting sector of innovation that he has termed distributed innovation, sometimes also user innovation, and most recently, Professor von Hippel has called this area of innovation democratizing innovation. And so he will be talking today about Democratizing Innovation, which is also, by the way, a book, it's the title of a book that he's published this year, which is available freely on the web under a Creative Commons license. So Creative Commons, as you may know, is the brainchild inter alia of Professor Boyle here at Duke Law School. So we're delighted that we have a confluence of such creative thinking between Professor von Hippel's book on democratizing innovation and the Creative Commons license. Professor von Hippel wrote a book in the 1988 called Sources of Innovation, and this book, Democratizing Innovation, is an extension and represents further thinking in this area. But obviously, he has been working in this area for a very long time, and we're just delighted to have him here. So without further ado, I will have Professor von Hippel speak.
Okay. Well, thanks, Artie. I hope we have fun. So what I want to do is tell you about work that is on the sources of innovation, and it's on what's happening nowadays, in a sense. A lot of work has focused on open source and so on. And what we really talk about, or what this work talks about, is the fact that you guys can come down front if you want. There's plenty down front. You can come. Okay, he says. All right. So yes, you can get it free on the web, and I'm going to walk you quickly through it, and then I'm going to talk a bit about something on norms on French chefs. Where Artie Ray knows a great deal more than I do, so we'll see how that one goes. Fine. So basically, what's up? Well, traditionally, the idea has been that one finds a need and fills it. That manufacturers are active, users are passive. Users have needs. You know, you sort of stand there looking very sad, and then over time, a manufacturer comes up to you and he sort of studies the target market, and he looks deep into your eyes and he says, you want rum-flavored toothpaste, do you? And he goes off and makes it. So again, the very idea of consumer is passive, right? And yet, this is really not working very well. About 75% of innovations, in the sense of projects and firms, fail. And so you have a really kind of a broken paradigm. So we have been over many years now studying where innovations really come from. And what you'll see is this other kind of a paradigm that fits into open source and related topics, which is that actually users innovate to solve their own needs. So Tim Berners-Lee, for example, was early. This is a dimension now of time. This is the number of people experiencing the need. Tim Berners-Lee, working at CERN, was early in trying to, or in facing the problem of networking disparate computers. And so he solved that problem in a user organization. The World Wide Web is what it became, and then that diffused out here and became a dominant product. So, or phenomenon. So that's the pattern, and it's a hugely different pattern. And what it implies for firms and so on is major shifts, because in effect you design your innovation process and your business models around the way you think the innovation process works. And if it's different, then there are significant implications that we might talk about a bit. Okay, so first, so that you know whether you believe me or not, let me give you 3 slides showing how we determined where innovations came from. What we did, and we did it across 11 fields, was we took a sample of major innovations. So if you look on the left here, this happens to be scientific instruments. But if you look on the left, you'll see gas chromatography, for example. That's a product line for a scientific instrument firm. And what would a scientific instrument firm or a producer of that product line be interested in? They'd want to know where the major innovations came from over time in that field. So what this sample represents is the biggest innovations over about 30 years in that field of gas chromatography. Ditto for those other 3 instrument types. So then what we did, and you can see in this sample here we have about 100 and something innovations. Then what we did was we began to look where these innovations come from. Because as you remember, the conventional wisdom is find a need and fill it. It is that somehow the manufacturers look at the users and see what they need, and they develop something. So we went out there and we began to look. And we went to the first firm to commercialize some of these things. Well, actually, the first firm to commercialize each of them. And we explored behind it to understand what the user's contribution was. And in 80% of the cases, we found that, in fact, the user had developed the first one, had published, in this case, or had used it to produce, or whatever the product was for, had actually used it, put it in use. So it wasn't just that the user had the idea, it was that the user built it. So for example, lead in blood detection. The levels of lead in blood that were causing brain damage couldn't be measured at the time. And so doctors doing the research, trying to measure this thing, are the ones who improved the device. There are a couple of seats over down here if you want. They improved the device. They then made their measurements, reported them, but they also reported how they improved the device. Other people began to pick up the thing, and after 5 to 7 years on average, the first commercial device was produced. So in other words, instead of having a system where the manufacturer is looking and figuring out what you need, you do seem to have this pattern here where users are innovating. Now, 2 interesting things about this. First of all, as I say, it moves the locus of innovation to a different place, and so you have to design things differently. The second issue that was really interesting was that the manufacturers didn't seem to know. The manufacturers who were producing things that had been developed by users were not aware, in general, where they came from. They had a system in place. They had a marketing research system in place. They had an R&D system in place. And basically what would happen would be somebody would come in from the field or something like that and say, hey, coming around the standard procedure and say, hey, look, I saw somebody modify this in the field. Isn't this a good idea? Management would later look at that and say, guess our conventional machine worked again. By God, we know how to do this stuff. Now, there's an additional reason why. Here's the data on this one, about 80% user. Not just the idea, but built and developed and used. Another reason why is that the users basically take things that are around. They put it together to solve their own purpose. So what you see is a scientific instrument here, a user prototype, and if a manufacturer looks at it, they say, well, that's great. Automated radioimmunoassay system, first one, yeah, we should build that. But look, they didn't build it. It's no product. Doesn't have room for HP in the corner. What kind of a crummy... So basically, there's more that the manufacturer has to do to make this a manufacturable product. So the engineers work on it, and they make it better. And after a while, the engineers begin to say, you know what? That thing that the users did was pretty crummy relative to our marvelous device. And then marketing comes in and says, buy our marvelous new product. And after 10 or 20 or 30 years, they think they did it. This is a problem because, in fact, if innovations don't come from where you think they do, again, there are implications for how you design the innovation process. Okay, so here's another one. Once you sort of see this kind of thing, you see user innovations all over the place. This is center pivot irrigation. And if you ever fly over the country, you'll sort of see all these circles. And this is was a major innovation in agriculture. And it took a sort of a mental leap to do it. What it is a sprinkler system, basically going around in circles. And there's a well at the center of each one. And the mental change was that you had to think that, oh my gosh, under my fields, and for the next few hundred miles, there's an aquifer that actually goes 20 feet below the surface or something. So the well is not the scarce resource, because what they had been doing was sort of digging a well somewhere on the farm and running pipes all over the place. Anyway, major innovation, and most agricultural innovations that we've tracked, again, are done by users. Here's the first one. And again, what you can see is that the user takes what's around. So this is actually the original center pivot irrigation built by a farmer. This was the pipe that they used to lay out on the fields. It's suspended on towers. You can see these old agricultural implement wheels here. And there's sort of a little piston thing, and what it does is the water going through this thing to come out of the irrigation heads actually also drives the tower around by moving that piston there. Here's a modern version, considerably cleaned up, as you can see, but same operating principles. So I couldn't resist. I called them up. This is the Valmont company. It's a dominant company in this field. I called them up and I said, so who invented this wonderful device? Are you or someone else? And they said, well, we did, my son. And I said, well, did you get any input from users living or dead? And they said, certainly not. And when you send us a plaque, be sure to spell our names right. So, companies, here's a wonderful one in a more modern area. Companies generally don't understand that. You know that GE brings good things to life. You've heard that, right? Their slogan. And here it is. Here's an ad. Companies just don't understand where their innovation comes from. GE advertisement. GE advanced applications leapfrog the industry. This is a particular one. Anybody ever had an MRI? Or you know about them anyway? So you can't wiggle. You put your head in this thing and you can't wiggle, because if you wiggle, the image gets messed up. Here. And this is hard for kids and for people with Parkinson's and stuff like that. So what a major advance in this area is that you can actually have a computer straighten out the image so that even if you wiggle your head, the image comes out straight. And I talked to a guy named Mike Harsh, who actually is in GE, ran the MRI area. And he said, yeah, we bring good things to life. And I said, that's good. Let's go back and look at where your innovations really came from that you brought to life. And we did, and they're basically all user innovations. Here's the list. And it's users. And so really, again, GE is now getting reasonably well coordinated at picking this up. But one of the issues is learning where they come from, and then the second issue is figuring out what to do about it. Well, consumer products as well. Gatorade, you probably know about. Protein-based shampoo. These are individual users, and mountain bikes and so on. Protein-based shampoo, women were putting egg and guacamole and stuff like that in their hair long before Procter & Gamble, quote, invented hair conditioners with protein in it. Mountain bike kids were running down the mountains on bikes and modifying and changing them and building them long before manufacturers got involved. Okay, so now, here's an essential definition about what I mean by user. An innovation is a user innovation when the developer expects to benefit by using it. This can be a firm or an individual. So, for example, Boeing, if they are developing a new machine tool or machining method, that's a user innovation because they don't want to sell that. They want to build airplanes using the method. If that same firm, Boeing, builds a new airliner, that's a manufacturer innovation because they expect to benefit from selling it. Okay, so whether you're an individual person or a firm, what we're talking about is your relationship to the innovation. Do you expect to benefit from using it or by manufacturing it? Now, what do we know about this? Since that time, the next thing we began to do was try to understand whether innovation by users was a rare phenomenon or a pretty common one. And this is 8 studies in both the area of industrial products and consumer products. And what you see is there's a lot of user innovation going on. It is not just that an occasional mad user in the heat of the summer comes up with something. It tends to be fairly common. Now, what do these things look like? This is not samples that are all users in a particular area. What it is, these are samples of people who care a lot about a particular type of innovation. So, for example, surgical equipment. 22% of surgeons are modifying their equipment. What surgeons? Surgeons who work in university clinics, in Germany in this case. So it's not like you will find 22% of all surgeons in community hospitals or whatever innovating. You'll find 22% of people who are sort of at the leading edge of that innovating. Analogously here, mountain biking equipment. 20% of those people innovate. Well, 20% of what? If I go around to your bike stands here, I'm sure I won't find 20% of the bikes homemade or modified. The 20% refers to a population of users who are in the area. They are serious mountain bikers, and they are on the north slope of the U.S., which is what they call it, Washington and British Columbia and so on. I think British Columbia over there. Anyway, Washington and something. Anyway, where they're pushing this stuff, and these are simply a sample of bike club members from that area, members of serious bike clubs. So, not every user, but a significant fraction of people who care a lot. And this can amount to millions of users. This one here is kind of interesting, outdoor products. This is just people who got the LL Bean catalog. They cared that much about outdoor stuff. And they had modified, 10% of them had modified some element of outdoor equipment that they used. Okay, so why do so many users develop products for themselves? Because many have custom needs. When you do a meta-analysis of market segmentation studies, which are sort of studies that companies do to say, well, there's the luxury part of our market, and there's the utility part, and the this and the that. When you actually study where the amount of variance that is within each of these 5 or so clusters that they generate versus between them, what you find is that half the variance is within segment. In other words, there are a lot of people that are pretty miserable with what people are selling them who are buying stuff, because what manufacturers want to do is they simply want to get a standard product that will induce you to buy, that's better than anything else out there. And that's all it has to be. It doesn't have to be best for your needs. It just has to be the best option. And when you actually look at people who are settling for the best option is often not very good. So people start to innovate for their own purposes. Now, what do we know about user innovation? We know that many users innovate. We know that users tend to develop functionally novel innovations, and manufacturers tend to develop dimension of merit improvements, and users that innovate tend to be lead users. Let me tell you a bit about that. First of all, it's not true that users are the only innovators always innovating. I thought, this is so cool. I'm not a great fan of marketing research, so I thought this was so cool when I first saw in that first study up there, Scientific Instruments, that 80% of these things were done by users. I thought, yes! But then I went down and began to look at other areas, and what we found was, damn, in some other areas, in fact, manufacturers innovate. So, making lemonade out of lemons, what you can then do is say, aha, isn't this marvelous? You can say, I can now sort of study this variation, and I can try to understand why in some areas users are just standing there not innovating, in other areas they are. Part of it has to do with, we did a lot of analysis of this, part of it has to do with economic benefit. For instance, engineering plastics, you can see here, are largely done by users, manufacturers. And the reason is that users don't really care a lot, typically. An engineering plastic that's new is a replacement for an existing engineering material at some slightly lower cost. So a user is not really driven into a corner in a way that they have to innovate in order to get done what they need to get done. In other areas, as you'll see in a minute, users do have to. So users tend to develop functionally novel innovations, like the first scientific instrument of a new type, the first sports nutrition bar. Manufacturers tend to develop dimension of merit improvements. So, for example, when I was looking at functional foods, for some reason that since escapes me, long before power bars and those things that you eat, or you may eat, the Olympic athletes and their trainers were developing these equivalents. So were the Navy SEALs, because they really needed this stuff. And they are such finely tuned athletes that they could actually sort of run along and say, yeah, I jump a millimeter higher if I eat this sort of combination of ingredients. So long before the manufacturer came out with that stuff, the users had sorted it out, and then the manufacturers made it better tasting and so on. Now here you see some data on this again, new functional capability users, dimension of merit improvements, manufacturers. Now dimension of merit improvement is basically once you know that the user wants a certain thing, sometimes the user states what he wants in dimensional terms. So for example, you would have, I want the fastest computer possible. Or, I really don't want a laptop like this. I want, the computer embedded in my eyelash. And so what the manufacturers are doing is steadily moving down these dimensional statements as fast as technology will allow. And that's something manufacturers are pretty good at. They're pretty good at sort of moving down a particular solution path. So, now why is that the case? Why do user and manufacturer innovations differ? It has to do with sticky information. Information needed by developers may be tacit, for example. Marketing research assumes that what we have if we have a need, the manufacturer can come and via marketing research learn what it is. But in fact, it's awfully hard to transfer information. Information is, as I say, sticky. So for example, my son, who's now 10, about 4 years ago, I taught him how to ride a bike. And I know how to ride a bike. And so I noticed myself teaching him in a bizarre way. I mean, yelling useless information, right? Poor kid, like, don't fall down, I mean, wonderful. Or pedal, pedal, pedal. Well, anyway, now why was that? The reason, even though I knew perfectly well how to do it, I couldn't tell him because, in fact, the information was encoded in my muscles. It wasn't sort of something that I had learned to express in verbal terms and transmit to him that way. So there's lots of information that's tacit. It's also true that there's just lots of information too rich to transfer. So now, sticky information again. Now again, the question about users and manufacturers, why do they have different innovations? So here we have over here need information, which the users tend to know in their context of use, and here we have solution information. And you have to put them together somehow. And so what you see is basically that the conventional wisdom is that the manufacturer will bring in need information from the user. That's the top circle and box there. That's the standard, that the manufacturer will bring it in and the user and design something. But in some cases, in fact, then if the information on this side about the need is stickier, then logically, to reduce cost, what you want to do is shift the information, the solution information here. So one of the wonderful things about it, I remember this thing about there's a box that you use when you're surf casting. I don't know what it's called, but you pull out your line so that you don't have the resistance of the reel when you're casting. You pull out the amount of line you think you need and you drop it into this little box, and you cast. Now, there was a big issue about how you shape this box so that it doesn't get in the way of your arm and stuff like that. And these manufacturers were standing around saying things like, well, imagine you're at the ocean, and imagine the waves are such and such, and imagine you knew how to fish. Well, now, all that was required to adjust the box was a pair of shears. You know? So instead of trying to figure out how the heck those people are going to use the box, why not give a pair of shears to the fisherman and let the fisherman adjust the box himself? And so that's this kind of issue here. You go to where the information is, where the sticky information resides. Now, one of the consequences of that is that you see not only user and manufacturer innovations differing, but you see that the innovations differ among different users. So here's a cool one. I don't know if you ever, do any of you know about this Camelback thing? Do you know about that? Some of you? Yeah. Okay. Well, they used to be called canteens, but now, of course, they're hydration systems. And it's a bag of water, basically, and there's a tube that so you put on this bag of water like a backpack, and there's a tube, and you suck through the tube. Now, where did that come from? Many people use them now. Camelback's patented personal hydration system was invented in 1988 by a Texas paramedic, Michael Edison. To prevent dehydration during a summer bike race, he fashioned a drinking system for surgical tubing in an IV bag. Now, the point was, this person combined two things. He had solution technology that was in his EMS truck, right? Like an IV bag. And he was a biker in the summer. So he happened to combine, in a very useful way, those need and solution informations and produce an innovation. Now, the result of this kind of localness, then, is that innovation is widely distributed. First of all, what have I said so far? When users innovate, well, a lot of innovations are done by users. User innovations tend to be functionally novel. We now understand why this is, namely, the information that users has to do with functionality and need, tend to be functionally novel, and users tend to use the information that they themselves have locally. Consequence, innovation is widely distributed. There's not a super user out there that comes up with lots of innovations. Instead, what you have is individual users or individual firms with particular sets of needs coming up with something. Now, that means that you don't necessarily know in advance. You know, what a company will often say is, well, if we see that users innovate, that's quite nice. We'll simply acquire a user and he'll innovate for us. But that's not the issue here. You can't necessarily tell who the innovator is going to be until, in fact, that innovation occurs, because you don't really know what that combination that is fruitful will turn out to be. Okay, the underlying logic is the same as Eric Raymond used when he coined Linus's Law. How many of you know Linus's Law? You must, some, yeah? Mm-hmm. It's an open source software. Given enough eyeballs, all bugs are shallow. Given a large enough beta tester and co-developer base, almost every problem will be characterized quickly and the fix obvious to someone. Each user approaches the task of bug characterization with a slightly different perceptual set and analytical toolkit, different angle on the problem. So, adding more beta testers increases the probability that somebody's toolkit will match the problem in such a way that the bug is shallow to that person. Shallow means easy to solve. Okay, now, another item here. Lead users. Lead users have needs that foreshadow general demand. This is just a definition made up out of the air a few years ago. And it was simply combining two characteristics. One characteristic, the bottom one, was basically necessity is the mother of invention. In other words, people who need something a lot, you know, the economics shows, tend to do something about it. The next piece was that the users that manufacturers would care about and that other users would care about are lead users, namely those that have needs that foreshadow general demand in the marketplace. So the point there is, if you think about it, that why was Tim Berners-Lee's innovation interesting? It was interesting because it was generally important after a while. So we wanted to get at that subset of users. So basically you have dimensions. I'm going to, what this shows, I'm going to start to go faster. I can see now I'm in deep, 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 deep trouble. Deep, deep trouble. Anyway, okay, so here are lead users. Here are users of printed circuit boards. This is a printed circuit board, and the use here is to lay out these printed circuit boards. The dimension here, the head of the demand, where the market is going, is that people are trying to make these boards denser and denser. They're trying to smash them together, make them smaller. If you look, you find something very interesting. If you say, do they have the two characteristics of lead users? Namely, are they at the front of the high density trend? That's one of the characteristics, and those are actual measures of things, number of layers and so on. And do they have a high need for an improved system? You find something quite remarkable. Namely, did you build your own system? 80% yes of the lead users, essentially nobody in the other ones. So what you have is a concentration we did not expect of users who are innovating at the front end, and at the same time, these people are the most useful user innovators. So there's some data on this, and the larger the circle, the more attractive the innovation commercially, and so that's what you see. Basically, the two characteristics of the user's expected benefit goes up, more user innovation, user position on the trend goes up, more attractiveness. The diameter of the orange is the attractiveness commercially. Okay, so now what happens? We have the beginnings of a new innovation system. Basically, users tend to innovate at the leading edge of markets. We said that innovation is concentrated amongst lead users, where demand is small and uncertain. So what we have is basically users innovating where manufacturers don't necessarily want to be. They're innovating on novel things. Manufacturers look over and they say, we don't understand that market at all, and it's tiny anyway. And manufacturers are more secure and can produce in volume when, in fact, it gets somewhat over here. So the idea to make the innovation process more effective would be to say, okay, what we have here is a process of looking here traditionally, bad idea. Let's look here, and then let's wait a bit and see and choose your entry point when you want to, in fact, produce this thing. What you see is that over time, and I'll show you in a minute, you end up with user communities. So first an individual user innovates, then multiples of users innovate, and pretty soon you can start to see what the commercially attractive ones are going to be, and then manufacturers have their uncertainty reduced and can go on and do something about it. So here's an example. Rodeo kayaking, something that you all are specialized in. Anybody rodeo kayak here? No. Yes, you. Yes, right. He does. Okay, rodeo kayaking. So rodeo kayaking is something that only Bob would do. It amounts to basically many, many years ago, people were trying to stay out of white water because their kayaks would get destroyed. And then they began to decide they would get into white water because that was much more fun. And gradually over time, the nature of the kayak that was most appropriate for this purpose became this form here, and it moved on from here and here. So what you have here is a set of innovations. And what you can see is that, in fact, when you study these industries, that's the pattern that I mentioned to you first. First, users innovate. They develop all these things, and then they become manufactured products. Now, I'm going to jump across that. Now, this is something that you all know. The thing that begins to make this something very interesting and useful for manufacturers and for the innovation process as a whole is the fact that users freely reveal their innovations. Generally. We've done studies on it. In open source, people have done studies on it. Users freely reveal typically what they develop. Now, that's terrific because if you're thinking about this from an economic perspective, when manufacturers innovate, are you walking?
User-based innovation to my kneecap.
Oh, you poor guy. My sympathies. Well, you missed the whole thing. But I'm glad you're here. You read the book. Okay, there we go. You can see if it's the same story. Okay, so now, in this area, users, when they freely reveal, you have something where you don't have to reinvent each time. If each user kept it secret, then from a system point of view, you wouldn't have a very efficient overall innovation system. If each user innovated, then every user that had the same need would have to do it again if the innovation were kept secret. And the manufacturer would have the comparative advantage because a manufacturer innovating once might keep something about it secret, but still would sell it to everybody so that people would not have to innovate and re-innovate again and again. So people here have, in fact, studied this, as I have and we have, as to the reasons why people freely reveal their innovations. And it turns out that basically the options for making money and licensing them are relatively cumbersome relative to the benefits you can get by freely revealing. And one of the benefits you get from freely revealing is that you can innovate collaboratively in communities. So now let's see if I have here. So now, here we have a history, basically. We have users starting to open a design space. They innovate, they do something. Very quickly, they join into communities and share their innovations. Then what happens over time is that the volume increases and manufacturers begin to produce this stuff. So we've begun to explore what goes on in these communities, and manufacturers are trying to hook up to these communities. And it's sort of all fascinating. It's just in the process of being worked on now. But it's so interesting because manufacturers in general don't know how to work with these communities at all. So they'll do something, like in the rodeo kayaking community, they'll say, "This is so cool that you are innovating. We are so proud of you. It's so wonderful. You all collaborate, don't you?" "Oh, yes. We love each other deeply." Well, that's really good, because now what we're going to do is we're going to give the best of you, who we're going to select, T-shirts with our company name on it. And you can start to mess with our next generation boat, but don't tell anybody else. So in effect, they come in and they corrupt the community. The very thing that they wanted to see happen, namely sort of collective innovation. It's like in the Russians in the old days when they would shoot any peasant that put his head up. Basically, every time the best of the best stands up, they say, "Yes, we'll take you out of the community and make you one of ours." Anyway, so there's clearly a lot that has to be learned here about how the communities can best be managed. Now, but still, there's a fascinating thing going on, which is that this kind of innovation amongst communities with the internet is getting to the point where it is driving manufacturers back out of product design. Even when manufacturers are established in product design, they're driving them back out. And I think this is just so cool. So there was a story, I'll tell you a story about kite surfing. This is what kite surfing equipment looks like. I'm sure there's 17 kite surfers in this group. Is this correct? I'm not either. But this is what kite surfing is. And the history, so what it is you basically zooming along on a board like this. In that sense, it's surfing. But what you're doing is you're in a really big man-powered kite. And the man-powered kite is so big that it can lift you off the ground. See those people there off the water? And all these wires here and so on are to control the kite and steer it. And you can go, tens of meters into the air. So you might as well know how to manage your kite, because dropping down is not considered a great idea. Considered a reverse parachute. Now, the users developed this stuff. And then, in this pattern I showed you earlier, the manufacturers began to move in. It became a $100 million market, and the manufacturers began to each hire one or two engineers, and they started to produce kites. Along came a guy named Saul Griffith, who was at MIT. He graduated last year. And he was a mad kite surfer. He would even surf in the Charles River, which is certain death if you fall in. And so what he did was he began to post these innovations on a kite surfing website called zeroprestige.com. And he would post these things, and others would begin to post them, and all the damnedest stuff would come up, like a a group in Russia was making them out of trash bags and so on and so forth and so on and so forth. And people were making better designs than the manufacturers is what happened after a bit. The fascinating thing was that when you looked at the composition of the site, these people were much better than the manufacturers, technically. They were actually kite surfers, and they were also aerodynamicists from General Dynamics, or aerodynamicists from NASA, or they were aerodynamicists from MIT. And here are the companies with these poor 3 or 4, MBA engineers or something like that, and it's like, oh, so they developed tools actually it turns out to be quite sophisticated. Low-speed aerodynamics is not a well-understood area, and these kites are going quite slowly. And so basically, there's all sorts of vortices and so on. They began to model this stuff, and it was just incredible. And when you call up the manufacturers, they say, I don't know. Anyway, so then they began to post their designs, and they learned that they could post their designs in CAD files, which then could be produced in sail lofts with laser cutters. So basically what would happen would be, this is a sketch, an early one, but later they began to post them in CAD files, and you could actually just send this CAD file off to your local sail loft. They would cut the stuff for you, and you could make a kite for about 20% of the cost of a purchased one. So, again, what happened was that the manufacturers began to be driven back from design. Now, this is to me very interesting because this is, first of all, a physical product. In open source, we sort of see it in information products. But products are increasingly information products later and later in their design cycle because what they're doing is exchanging CAD files. And so this is a relatively, possibly general thing. It also means that what you've got here is this kind of democratized innovation where people are innovating from different angles and producing and contributing and so on and moving things forward rapidly. So it can be very cool life where, in fact, we can finally design what we really want. Manufacturers can start to pick off the stuff that people in general want. Now, learning by doing can be incredibly cheap for users within their own narrow niche of doing. What you're doing there is you're figuring out how to do things. And it's, it would be very hard for a manufacturer observer to figure out what was going on there and say, what you need is a... Okay. Now, what we're focusing on now is companies, is user innovation communities. We're just sort of very interested in that. And companies, as I said, are having a very difficult time with it so far. So any of you know about Lego Mindstorms? Do you know about that? Yeah? Isn't that cool? Well, Lego Mindstorms was built sort of with work with Lego and MIT, and there were about 3 engineers in Lego who worked on it for some large number of years, like 7 years. And what it is basically Lego blocks that have different kinds of electronics in them as well. So there's a CPU, and there's all this sort of stuff. There's sensors and so on. So you can get this stuff to build it into robots that respond to temperature and light and touch, and the kids can program it. Well, about $200. They expected 8 to 13-year-olds to buy it. So after 3 engineers, 7 years, 21 man years, they introduced this thing. They said, ta-da, which is what you say. Within 3 weeks, 1,000 hackers were working on it. And 1,000 is more than 3. And what happened was, so it cracks me up. Anyway, what happens was that they vastly improved it, almost instantly. So they then began to sort of publish what they'd done on the web. So here's one of the things you do with this thing is with your sensor, you follow a track like this. You build up a robot and you follow a track, and one of the contests is how rapidly you can get around this track of tape. And they began to publish how much better their stuff was than the Lego stuff. So the winner, using hacker-developed software, under 10 seconds, second place below right, user program based on Lego firmware, time of 25 seconds. We're better. Basically, Mindstorm sales, it helped Lego. Their sales greatly surpassed their expectations. 70% of the customers were over age 18 and weren't what they expected. Craze among techie adults. Silicon Valley firms forced to ban Legos at work. Anyway, major universities build curricula around Lego. We have something like that at MIT, sort of hacker. It's a great way to let people hack. And then Lego unable to keep up with demand and so on, sales much higher. What was the response of Lego? There was almost a full year without a word from Lego, neither acknowledgement of what was going on nor threats toward the hackers. They didn't know what to do. They were deer in the headlights. Well, now, about 10 years later, they have started to understand this. And what you see now is the first generation of painful understanding by companies of this new transition where the users are much more active in innovation than they used to be and the manufacturers build it. So they have now posted something just a week ago called the Lego Factory, where they are urging people to design stuff that they might then build as kits. And of course, they have a Lego Digital Designer, which is a virtual thing and so on. And I had my students try it out, and of course it's nowhere near as good as the hacker thing. They could have just taken the hacker virtual, but no. Anyway, but they're on their way. Now, better practice, when you think about it, here's Stata Corporation. Any of you use static software? Anyway, some. You do.
I have it.
You have it. Stata software, basically, Stata is starting to be systematic about this. Statistical software for academics and so on, and Stata realized that they are not the ones who develop the new tests. It's the epidemiologists and so on, the people who need the tests, the statisticians and so on, and people who are trying to do something. So what they did was they developed a core product, which they could predict, and then basically users could build modules onto that and run them. So what happened was users did that. What you're seeing here is a hybrid model of sort of proprietary and open. Users built modules. The manufacturer then looked at the user site where these modules were freely revealed and said, we can see which ones of those are most popular. And the ones that are most popular, we will incorporate into our product. So it's so cool. The users build this thing. They exchange it with each other. You can observe the patterns of activity, and you can decide which ones you then want to make as a commercial product. And interestingly enough, Dietmar Harhoff took a look at these Stata people and what they feel about this and the users, and they feel delighted. This is a true symbiotic relationship. It's not that they feel ripped off. Basically, the users, one of the things that happens when you design a statistical test is that the users, that you have to validate it. You have to sort of test it out across a wide range of conditions. And no statistician likes to do it. It's a pain in the neck. But it's sort of embarrassing if you release it and it works well in your area and it doesn't work in somebody else's and they get mad at you. So they're quite happy that Stata does the hard work of QC and test validation. By the way, they also rewrite the user code as they do that, thus gaining the copyright, and integrate it into the core product. But they fully acknowledge the user innovations. They say, this is Joe's test. Isn't Joe clever? Send me $10. So it's one of the forms now of user-manufacturer collaboration that are being worked out. You see this also in online computer game manufacturers, giving users tools to develop game mods and so on. Again, this is the first generation in these things. So the first thing that happened not so long ago was not that manufacturers said, this is a cool idea, this is the way we should go. What happened was the users cracked some existing games, started to build mods. The manufacturers noticed that everybody else was adopting their mods and playing them instead of the games the manufacturer built. So the manufacturer said, okay, we're going to control what's called the engine software and not let the users mess with that. That's the thing which basically computes when you throw a ball that it curves like this, or you can throw a spear or whatever it is. And then the user devises everything like, are we talking about kids throwing spitballs in the library, or are we talking about outer space creatures and flying stuff? So anyway, so that's the story again, that I would argue that we're shifting from this kind of an argument, which is really a broken paradigm. As I say, most innovations the manufacturers attempt fail, and they tend to fail because they don't understand user need, to this kind of symbiotic story where users who really need something innovate, and then manufacturers pick it up. There's something really cool going on now, which is I'm really happy about the policy implications. This is so cool. The Danish government has gone ahead and now made user innovation a national priority. Strengthening user-driven innovation and knowledge diffusion, the government will develop a particular program, so-called user-driven innovation, et cetera, et cetera, et cetera. So so we're now going to, with the University of Copenhagen and the government over there and so on, we're going to try to do this on a national, small nation, I confess, but we're trying to do this on a national scale, and then if it messes up, we will quietly creep away, you know. And, but anyway, it's sort of companies are perceiving that it's a problem and so on. Now we have a couple of options here. One is, I was going to tell you a bit about French chefs, but like a non-fool, last night I had dinner with James and Artie and so on, and I said, "So, what do you think about this thing?" And they said, "Well, that's very new." And I said, "Oh, it is? Yes, you said that. Certainly no more than 30,000 articles on that." And I so we looked at each other, you know, it was about norms and French chefs and so on, and because I'm very interested now in communities and how they behave, and so we were just stumbling across this kind of behavior. So they looked at each other and they said, so I said, "Was there anything on this?" And they said, "Nothing on French chefs. Yes, Estonian chefs, yes, but nothing on French chefs." So I think I could tell you some data on that, but I think maybe there are two options here. One is you could ask some questions and have comments. We have 7 minutes left. Another is I can show you 7 minutes of Dogtown and Z-Boys, which shows you an actual user community. So are there questions? You want to see Dogtown? What? Yes.
So I'm a computer programmer. I take part in a lot of open source software, and I can tell you that there's definitely a lot of really, really horrible open source software out there. I think the reason that these communities get a lot of visibility is just because they're so much larger than everything else, and they don't have to go through a lot of the steps that the manufacturers. I mean, it started up with things like quality assurance, but there's also things like liability that they don't really have to worry about. But studies in computer science have shown that popularity of a lot of things like websites, but also open source projects like on SourceForge, follow a Poisson type distribution where you have a very few, very popular, very large user community, but then tremendous amounts of essentially deadwood that's out there. So I think I see that. I guess, could you address whether or not the reason that these user communities are so successful is just because they're so much larger compared to the manufacturers, or is there just something inherently smarter about these user communities than the manufacturers?
Well, when you study actually study, we've done lots of, and other people have done lots of studies of open source. When you study, what you find out is that the core community, you know, the guys with commit license, as opposed to the periphery, have different functions. The periphery tends to come up with new stuff they need, and the core tends to make it faster, cleaner, neater, please. Now, so there is a benefit of being able to innovate yourself and get what you want. A second issue is, do other people want it too? Now, the fact that a community is small, and the static community is small too, doesn't mean it's not serving a function for those folks. The equivalent of a very large community might serve a very large and general need, but the real freedom you're getting here is that whatever the scale of need, you can get something for it. Now, there are also sort of hobby projects that serve nobody's need in particular, and a lot of the dead wood is sort of, you know, I mean, not all projects are successful because users do them. I mean, but the idea is that you're not having a manufacturer speculate on what will be successful and invest in it. You're having users, for purposes of their own, making private investments, whether they're firms or individuals, and so you know, can make that determination for themselves. Yeah.
You may have covered this.
I did.
But have you done any studies on the demographics of particularly innovative user communities, and or compared those demographics to the figures that we have as of rates of entrepreneurialism in different populations?
There have been some on open source communities. It depends. In open source, tends to be it is not all kids, of 13 years of age. It is a lot of them are professionals, programmers who are doing it on the side and so on. And I can send you a study like that. Some of these things are very much a function of who needs it, who's a user. So in these sports communities, they're younger. In the Stata community, they're older. And in fact, in the skateboarding community, a lot of them were age 13. Just a parenthesis, which is not at all what you're asking about, a parenthesis. Do you know skateboards are now like this wide, right? Or whatever they are, like that. And they started out this wide. And there were 2x4s that you put skate things under. And the reason they first got this wide was because kids were making these things and making them for each other. And one kid kept on taking the last one he'd done and drawing around that one with a pencil to make the next one. So each time it got a pencil width bigger and putting it together. And people started coming back to him saying, those are cool boards. And that was the observation that then led to the wider board becoming a standard. So, yes.
Since this is a law school and we have to put in the dismal, science to the extent of science of law into all of this, I'm curious as to how patents fit into all of this. Do companies that that approach these user communities then try to get patents, and do they name the user community members as inventors? Do you have any sense of, in your studies, of how that works? So I seem to recall somebody saying in one of your conferences that in some cases the manufacturer will actually patent the stuff and exclude the users from using the particular innovation, or attempt to get them to pay to use the particular innovation.
Well, they are evil to the core. There's no question about it. But it depends again on the community. Like medical communities, okay, they will tend to patent. And sports communities, yes, sports communities will not. In part because it's unlikely, and in part because they're freely revealing. This is a community thing. Everybody's seeing what you're doing. You've got a new bike, they take a look, they say, that's really cool. So it differs by communities, but it's not a big deal. It's not a big deal in general. Yeah.
Well, following, I had one paradoxical observation was that the Danish government that's out there encouraging its people to do this is probably also out there in Geneva opposing the recognition of traditional knowledge as intellectual property, right? When in fact it's actually doing the same thing. And it is the oldest form of cumulative innovation that we know. If you think about agricultural innovation, it's always been done the same way. I wonder if you've thought about, in line with Artie, if you thought about ways of incenting these user communities in ways that don't hurt the community, but could make it more systematic. That is, everything that you and lots of other people like to talk about is this romantic anarchism, how it all works out so beautifully. But often it doesn't, and often they fail, and we have no real records of these anarchic communities surviving very long. So in the case that we might need something more systematic, might we not find some way of incenting these communities in a way that might draw more user communities into it, not just for the purpose of sport, but for purpose of systematic participation, and in a way that they could be compensated? I submit that we can, and that your studies are a great encouragement to those people who are looking for new ways to incent communities like this.
Oh. Well, that's cool. I mean, it may be two things. One is because we found this community phase is so important, we're now studying that. And so there's a paper that I gave at Fuqua yesterday, Wes can give you a copy, on sort of some of the economics that drive the users and the manufacturers and so on. But the other thing is, you've got to remember that this is different from open science. Open science has traditionally required subsidies from outside because they're not using their findings. These people are using this stuff. And so it's not obvious on the face of it that additional incentive is needed. What happens when you end up with communities that form spontaneously is that the people that need it most are the ones who are working on it. So, for example, there was development of a new medical thing, a way to better give drugs without mistakes. And this is a community amongst medical hospitals with people who are especially concerned. It's not obvious that they need more funding, although that's, again, an important variable we'd have to think about. Once you get that, though, you start to worry about things like, who gets the credit, who gets the money, it becomes difficult. No, because they get private benefit from use. See, sorry, go ahead.
Before we take further questions, it is 1:15, so I'd like to give anyone who needs to leave the opportunity to do so without feeling bad about it.
Oh no, you have to feel bad.
We should definitely give